Now that we've looked at some of the basics of using maps and avoiding inefficiencies like nested loops, let's look at some ways you can profile Apex trigger performance and troubleshoot problems. In Order Manager, you might notice that there are debug statements that print out the number of milliseconds consumed from each time the run method executes. This is true of each of the trigger handler classes included with the course example material. Here's how it works. At the beginning of the run method, there is the start time integer variable, which marks down the current CPU time using system.limits.getCPUTime. This method is one of many that allows one to retrieve information regarding a given governor limit category. Review the Salesforce documentation on the limits class, which is what's referred to here when indicating system.limits, as there are methods for getting counts on SOQL queries, the number of DML statements, and much more there. In this case, I've gotten the current CPU time. What this returns is a number that comes from the Salesforce server clock, and then down below, another integer variable stores the end time value. When subtracting the start time from the end time, that gives the total number of milliseconds from the difference. Of course, this means this same technique can be applied to measuring individual methods as well, although you might be careful in considering adding time markers all over the place on a whim, as that may become unwieldy. Debug statements can then be reviewed in a log to let you know how long certain operations take and, naturally, show how many times the operations you're measuring execute. This is visible if, say, running Apex tests that execute the code block being measured, which then makes the system.debug method call to display the log statement. From the developer console, a great way to examine an entire transaction is to run it, collect the logs, and then examine the overall view from the analysis perspective. To get to the analysis perspective, go to Debug, then to Perspective Manager, select Analysis, and then Open. Most often, I like to use the Timeline tab, but this other information here on the other tabs can certainly be useful depending on what you're after. The Timeline tab view shows a breakdown across time within the run context or transaction by the different categories of logic execution: Apex code, workflow, interacting with the database, validation rules, web callouts, and when you're working with Visualforce, even activity from Visualforce components. Below, you can readjust the scale for what makes sense visually, ranging from entire minutes to fractions of a second. With many of the tests present here in the example code, there will only be the Apex code bar present here on this Timeline tab. This is because many of the tests just run logic and make assertions against the results of that logic completely without interacting with the database. This is because many of the tests just run logic and make assertions against the results of that logic completely within memory. In some of the other tests, or perhaps in your own code, you'll see some database activity. The course examples do not contain any workflow rules or actions or flows that execute during object transactions. If you wanted to see anything under the workflow lane here, you'd have to add those components and make them active on a relevant object to see that here. Of course, if following the one tool per object rule, you'd hopefully not see workflow and Apex both running in different lanes on the same logs. But lots of orgs also do not follow that advice, and chances are high you may have to troubleshoot issues on transactions that have both tools active at the same time. One more thing. It is possible that you can adjust the granularity of the information displayed in these logs too. Go to Debug, then Change Log Levels, then Add/Change on the current log level displayed. Within any log level defined, you can adjust each of the categories to display information here at a finer level or a lesser level. This can help in general troubleshooting, of course, but may be limited in usefulness as far as understanding consumption of governor limits. Still, I wanted to point it out, as that may be part of the reason why, in some cases, you come across instances where you're not able to see the debug statements you're adding to your Apex code. And then trying to see things like those CPU time printouts or seeing how many queries are being consumed wouldn't be possible if the log level doesn't allow it. Always check here if you're having trouble. Make use of this perspective, the Salesforce limits class in Apex, its methods regarding governor limits, and debug statements where appropriate to track consumption against governor limits. And of course, make sure you check out other courses here on Pluralsight regarding debugging and troubleshooting on Salesforce.